Hello everyone, welcome to today's class on normalization, where we will discuss about how to improve our database design and what we should do in making those improvements. So this basically summarizes what we will be discussing about. We want to design, for example, a scheduling database where we will have tables for lectures and courses. It shows the ER diagram and the database relationship schema, and the goal is basically to fix errors and add constraint. And how do we do that? How do we make the database design better? How do we make sure that we are able to add constraint that will make our database design much more better and functional? Well, we can do that by, of course, working with functional dependencies and decomposing them using different normal forms, which is what we would do, and that helps us of course remove some anomalies in the database for either insert or update. So let's see what this week lecture will be fully. So normalization. Well, normalization basically is the process of organizing your database into tables and columns in a way such that you will be able to remove as many anomalies as possible. So it decomposes tables basically. When you have this big chunk of table where you have all the information, it's just like you have one big student table, you have all the information and all that. When the table grows, when the database grows, it becomes difficult to manage. You have issues that can occur. And let's take an example of this student table. For example, you see the student table, you can see there's a repetition of data. Let's say we need to enter information for 2,000 students, so you have to repeat all this information. That is a tedious task, and you can see what that lead to is just addition and repetition of stuff that you could actually avoid, and over time this can actually cause insertion anomalies. Insertion meaning you might have problem when you're trying to insert, especially when you have multiple tables, when you're trying to update or delete. I will explain that in the next slide where you see we'll discuss about each of them. So let's talk about the insertion anomaly, for example. So let's say we need to insert information for 10,000 or 4,000 students. It means you have to repeat all these whole columns in each row. That is one of the insertion anomalies I'm talking about. So the repetition and all that. And another example here is let's say we want to put an information for an employee. So what if we don't have the employee ID and the salesperson ID yet? So it means the table will be incomplete. So it means we will have an incomplete table, for example, and I'll give you a reason why this can actually occur when we go forward. So these are a couple of the examples. Deletion anomaly. When you, for example, for the students table, at the end of the students academic year, or maybe the study academic year, or rather when the student is done with the university and maybe graduated, if we have to delete the student record, we would also lose the data about the student's department and advice and telephone number, because everything, each row will be deleted, because that is what will happen. And if we only delete the student name and student ID, then we'll just have a duplicate here. So that doesn't make any sense, right? So this is one of the issues. So this is one of the problems you can have. And over here, let's say we have an employee table. If we should delete the employee row, maybe for example there's a change of employee or the employee left or something, in this case you will lose information, for example, about the sales office in New York and also the telephone number. So these are some of the things that can happen. So we are deleting the salesperson here, but in turn we also delete information that are actually crucial, because we need the phone number for New York, and that is gone. So it's important for us to do that. And for example, the customer that this salesperson is servicing is also gone. So it's important to understand some of these anomalies that can occur. So these are one of the problems you can have in database. And update anomaly. So for a student, let's assume that a student advisor left and there's a new advisor called Vicky, for example. As humans, it happens when you're updating. You might make a mistake instead of updating the whole table, so you might skip one. So this can happen where maybe you even skip the phone number or stuff. That way we have this problem of having wrong information in our database. And the same thing is for the employee table here, when we have to update so many rows, when we need to update information about the salesperson, like for example the office number in Chicago, and we will have to do that in multiple rows because we have two salesperson in the Chicago office, so meaning there will be a multiple update, which is really not needed, right? So how do we fix this? So normalization helps in that. So we have of course the first different forms. We have the first normal form, the second normal form, third normal form, and then the Boyce code normal form. This is sometimes known as the 3.5 normal form. In some places you might see that, so don't be surprised. So it's just BCNF also. And then we have the fourth normal form, and I've seen where they say there's fifth and even sixth normal form, but basically these are the major normal forms. You see a lot of the first, second, third, and fourth normal form. So I just wanted you to know that there's also the Boyce code normal form, and that is there. And these forms are basically progressive. So in order for you to qualify for second normal form, it has to satisfy first normal form. So for third normal form, you have to satisfy second normal form. So this is just to tell you that it's basically as you normalize your tables in database, they are all progressive. In order for you to say your table is in fourth normal form, it has to have satisfied the first, second, and third normal form. So that is just something you should pay attention to when normalizing your tables in database. So yeah, what's the first normal form? So the first normal form basically defines that we should make sure that each single value or columns has just atomic value, meaning it has just single values, not multiple, as we can see here. So here you can see that the column content has Java and C++. And also for the course web, we have HTML, PHP. So this is a table that is not normalized. And for us to normalize this into first normal form, we need to break this into additional rows. So for example, the programming will be broken into two additional rows. So we have programming and programming, and we have one just atomic value here, Java and C++, and the web will be broken into three rows where we have the HTML, PHP. So this is the rule for first normal form. Now for second normal form, basically second normal form requires that every non-prime attribute should be fully functional, dependent on a primary key. What that means is that well, before I go into that, first of all, let me specify. So basically a prime key is any attribute which is part of a candidate key. So and a non-prime attribute is any attribute that is not part of the primary key. So that is something you should know. So that's the difference between prime attribute and non-prime attribute. And of course, for a table to be in the second normal form, it should first be in the first normal form, and it should not have any partial dependency. So that is something that you should understand. At least I've said that earlier. So excuse me. Okay, sorry for that. So basically for the second normal form, as I was saying, there should only just be a single column primary key. So as you can see, as you can see in this example of our student project, we have the student ID that can be used to identify the student name and the project ID for the project name. As you can see, there's no single column. So that is what we are talking about, the partial dependencies. So you can see that we have multiple column key here. So in order for us to fix that, the first thing we need to do is to break that into two tables. So we should have a table student where we have the student ID, the student name, and the project ID. And then we should have another table called project where we have the project ID and the project name. So this is just to explain to you how to remove those partial dependency from a table. So this is the second normal form. And basically, of course, you can see that the project ID has a foreign key here. So that is a constraint we've added so that when we are updating or inserting, at least we have some certain level of integrity in our table. So that is something you should be aware of. If you remember in the first diagram, I think here, you see I was talking about I was fixing errors and at the same time adding constraints. So that is something I just want you to pay attention to. So now let's talk about the third normal form. So the third normal form basically states that the table has to be in the second normal form, and non-prime attributes non-prime attribute is sorry, I need to get water. Sorry for the coughing. Basically, as I was saying, so no non-prime attribute is transitively dependent on a prime key attribute. So that means that there should be no transitive functional dependency. As you can see from this example here, well, let me explain again, maybe if you don't get that clear. Basically, the transitive dependency is that when changing when changing a non-key column causes changes in other non-key columns. So this is called transitive functional dependency. So it's like an indirect way where one non-key column affects the other. So as you can see in this example here, neither zip or city is a prime candidate or attribute, for example. And if you make changes in either of city or zip, there's always an effect because both of them are non-key column, but a change in city will affect zip, and a change in zip definitely affects city. So that is a transitive dependency. In order for us to break this down, we need to make a change into breaking it in two tables. So we have the student detail table where we will have the student ID, the student name, and zip, and then we will have zip codes that has zip and the city. So this way there is no transitive dependency. So we make sure that we take that off. So it is to ensure that the table is in third normal form. So this is a little example for you to see how this work. And sorry for my voice because I think my cough is getting bad and that is affecting stuff. And now let's go to the third. So third normal form now. We talk about the big brother of the third normal form, which is the boys code normal form. Normally people call it the 3.5 or the boys code normal form or whatever people call that. But basically it is more a stricter form of the third normal form basically. So for any non-trivial functional dependencies there must be a super key, and for a relationship to be in the boys code normal form it has to first of all be in the third normal form, and each functional dependency S to Y S should be a super key. And let me use the previous example that we did. So as you can see in this example now, when we broke this table down into three, and before I go into that, one thing to note is that sometimes when a table is in third normal form, it can also satisfy the boys code normal form if each functional dependency has a super key, for example. So that is why I want to use this example to explain that to you. As you can see here, the student ID is the super key for the student table, for the student detail relation table here, and the zip is the super key for the zip code relation. So that is something to tell you that each table uniquely has a super key. A super key basically is a set of one or more keys that can be used to identify record uniquely in a table. So that is it. So basically you can see this is a real example to show you that a table can be in the third normal form and still satisfy the Boyce code normal form. So that is that for it. Now let's talk about the fourth normal form. So the fourth normal form, for a table to be in the fourth normal form, it has to be in the Boyce code normal form. This is an error, but I'm gonna fix that type of error, and it does not have a multi-value dependency. Oh my god. And a multi-value dependency. I'm sorry for the coughing. I hope I'm still able to pass my message and try to round up this video lecture quickly. So what is a multi-value dependency? So a multi-value dependency is, for example, when a single value in a column requires a multiple value of b to exist in the table. So that is basically a multi-value dependency, and that can only happen if you have at least minimum 3 columns in the table. I will show you that in a quick example here. So as you can see in this example here, you can see a student number 1 here has an address in Helsinki, a course, database, and hobby reading. So this time student 1 has 2 different kinds of hobby, which is reading and cycling, and student 2 here, well, has HCI and hockey, but both has different hobbies basically. Now one thing you should also note is that sometimes as we said, let me take that up. As we said earlier, for a table to be in a fourth normal form, it must first of all at least be in the Boyce code normal form. But there are times where a table can also have issues where there's still functional dependency and even multi-value dependency, and that is seen here. You can see that the student ID missed the address, so you need the student ID to be able to identify, okay, this is student 1's address. Same thing for courses, and same thing for hobby. So here you can see that there is a multi-value dependency from student ID, which is student number for this example. Oh, this is a typo error. I'm sorry about that. I'll fix that and continue. Sorry for the typo. I had to correct the student ID here because I wrote student number before. So as I was saying, sometimes you might have a situation where you might have issue of functional dependency and multi-value dependency when you're trying to actually transform a table into fourth normal form. So you can see here that address is functionally dependent on student ID, because for us to identify, okay, whose ID is whose address is this, we need to look at the student ID. And course has a multi-value dependency with student ID, same with hobby. So these two issues can arise, and for us to fix that, the best thing to do is to break this whole table into 3 other tables, and that will be a course table where we will have the student ID and course, we have the hobbies table where we have the student ID and hobby, and we have the address table where we have the student ID and address. So this way we try to fix the issue of multi-value dependency that can arise. So this is the example. I've given some weekly exercise and assignment for you to also practice and try to get familiar with normalization and how we create the first, second, and till fourth normal form. And I'm so sorry about my voice and cough. I just had to do this, but I've been having cough for since yesterday, so I'm sorry for that. I hope the video is clear enough and you're able to understand that. Well, with the exercise also, I believe that will also make you go through the lecture slide and the video to have more in-depth understanding.